Hi everyone, I'm Bernoulli. Chapter 2, Section 5, Bernoulli distribution and binomial distribution. Today's topic. I already introduced Bernoulli distribution previously, and I'd like to continue to explain binomial probability distribution function today. Let's see. What is a Bernoulli? Bernoulli distribution, Bernoulli random variable takes only two values, 1 or 0. Okay, I explained it. And what? Binomial, each probability distribution function is like this. F of x is p x power times 1 minus p, 1 minus x power, like this. And we thought about expectation of x and the variance of x, like this p and p times 1 minus p. Binomial distribution. Binomial is when the Bernoulli trial is repeated independently n times. Same Bernoulli trial is repeated n times. The distribution of number of successes follow a binomial distribution. Even though you do not know Bernoulli distribution, I think you are familiar with binomial distribution because some probability problem, can be solved by a binomial distribution. Anyway, specifically, population X follows Bernoulli distribution. Okay, population. In other words, random variable X follows Bernoulli distribution. Let X1 what repeated independently n times. So X1, X2, Xn. Capital letter means what? Random variables. Be referred to as first Bernoulli. Okay? X2 is the second Bernoulli. And Xn subscript n, Xn is nth Bernoulli trial. Then xi equal to 1 if success, xi equal to 0 if failure, right? I just add this subscription, okay? And what? P probability of xi equal to 1 equal to p. You may ignore I here, the same probability p, then sum of xi's, i.e. x equal to x1 plus x2 plus up to xn. Okay, summation I from 1 to n of xi. Here, x from 1 to n. Then, what is x? X means number of successes is said to follow binomial distribution. x1 takes 1 or 0. x2 may take 1 or 0. xn may take 1 or 0. So add all the x's is what? It's number of what? Successes, right? Understand it? And the probability distribution function for random variable x, binomial distribution, is f of x n combination x. This is n combination x, this notation. And the p power x, 1 minus p power n minus x. X takes from 0, 1, 2, up, dot, 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 n. Get it? Yeah, this is a famous binomial distribution function. Okay, what is n combination x? It's number of ways to get what? Successes out of n. Okay, and expect e of x, expectation of x is in this case np. Okay, expectation x is expectation of x1 plus x2 plus up to xn. Variance x is variance x1 plus x2 plus dot dot xn. So this is n many what? Bernoulli variance, like this. Bernoulli variance is p times 1 minus p. This is also n what? P. P is Bernoulli expectation, expected value. So there are n many here. Okay, you will understand this part after studying joint probability distribution function and what sample theory. Then you may understand these two well. For example, consider 10 multiple choice questions with 4 options each. Unfortunately, if a person who cannot solve any of these problems will guess randomly one of the 4 options, the probability of answering correctly is 1/4, right? There are 1 to up to 10 many multiple choice problem. Then somebody do not know the answer at all. Okay, 1, 2, 3, 4. Then what is the success probability of a success? Probability of a correct answer. It is 1/4. Each of them is Bernoulli, and the success rate will be 1/4. Okay? If we let the random variable x represent the number of correct answers, number of successes among the 10 questions, then x follows a binomial distribution function. Specifically, okay, if we denote xi as a Bernoulli random variable for ith question, then xi equal to 1 if correct, xi equal to 0 if not correct, like this. Okay, pxi equal to 1 is success rate 1/4, and the number of correct answers is x equal to x1 plus x2 up to x10. For example, probability that x equal to 6, in other words, number of correct answers is 6, okay, can be calculated using the probability distribution formula above one, this one, of the binomial distribution as follows. F of 6 is how many? N. N is 10. 10 combination 6, and success rate is 0.25 power 6. Okay, 6 can be number of correct answer is 6. So number of what non-correct is 4, right? 6 correct, 4 incorrect. So that probability is 0.75. So you can solve this kind of a thing, then you get the right answer for this question. But it is also very, very complicated, time-consuming problem. 0.25 power 6, okay? 0.75 power 6, also very, they will take time. So there is normal approximation to binomial distribution. Okay, we will study that kind of thing after central limit theorem. After sample theory and central limit theorem, then we can solve this kind of thing by normal distribution. Okay, that's it today. Thank you. Bye.